Hey YC, it's Pranay this side, and I'm building an AI inference runtime. Our mission is very simple. We want to make powerful AI run locally on hardware that traditionally it couldn't. This is the Inferno RTCLI interface, and over here there are a couple of ways you can interact with your LLM models. For today's demo, we'll be using a run command that is a single inference output, and we will be using an 8 billion parameter that was provided by Llama. And so to run this model, you will use this command. Over here, you can see we have given a hard memory budget of 4 GBs. You can also define your context and the thread CPU threads that you want to use for your runtime or for a specific inference as well. For backend, we have chosen CPU, but we right now also support MLX, metal acceleration. We are working towards bringing in CUDA as well as Qualcomm QNN networks, and this works on Linux as well. After that, you can have your prompt. Over here, we are using Kubernetes prompt to understand how the rolling deployment works in around 150 words. You can define your maximum tokens, and you can also have an option to let the models run until it decides that you know this is appropriate enough answer. And for the purge flag, it basically allows us to understand how the runtime interacts with the LLM models and how it is defining your memory. Where does that go? We have a couple of execution strategies. Over here, we are using streamed multi-segment vector because the runtime smartly knows which LLM models can fit on your RAM budget. And so over here, we this model is 4.6 GBs. And so instead of loading all of the model into your RAM, it only loads the active layers, which is over here in our case 2.94 GBs. And it can vary depending on your use case and your context limits. So before generating a single token, the runtime determines how it's going to execute the model within that very constraint that we've set over here of 4 GBs. And so while the model is running itself, Inferno is continuously managing the model residency and execution according to the plan that it computed before the inference even began. And the important part isn't that the model just runs. It's that the developers can target hardware with strict memory limits. And over here, as you can see, it used 3.26 GBs to generate that response, which is well below the 4 GB cap, and it did that under 2.24 tokens per second. You can see different variables of how much speed went there, how much memory was consumed, and how those buckets come into picture over here. Now, today's AI software is largely built for machines with abundant resources, and I think that the next wave of AI will run much closer to where it is used in factories, robots, vehicles, defense systems. So, Inferno RT is just the software layer that we're building, but our vision goes beyond that. And we're building the software foundations today, and we have a long term goal of enabling specialized AI hardware designed around the memory efficient interface. And we believe that local AI should become the default and not the exception. Thank you.